Hello viewers, I'm Kausalya. Today we are going to solve problems related with maximum power transfer theorem. The problem is determine the maximum power delivered to the load in the circuit shown in figure. So here this is the given circuit diagram and this is your load resistance RL. We need to calculate the maximum power delivered to this load resistance. Right. Here the first step is we are calculating the total resistance of this circuit. So for that purpose, again, this is our given problem. Here I have removed that load resistance RL, right? Here now we are going to calculate the resistance value. So here you see these two resistors are connected in series, so we can directly add. So 2 plus 3, that gives 5 ohms, right? And this 5 ohm, okay, this 5 ohm comes in parallel with this existing 5 ohm. So here the net resistance will be R1 into R2 divided by R1 plus R2, or else if we have the same value of resistors in parallel, then the net resistance value is half of its value, that is 5 by 2, here 2.5, right? Now the thing is that 2.5 resistor comes in series with this 10 ohm resistance, right? So 2.5 plus 10, so that gives the value of 12.5. Therefore, the total resistance is 12.5 here. So, the total current is given by I is equal to V by R. So, here the V is 50 volt and here the R is 12.5. So, here the answer is 4 amps. Now, we have calculated the total current and total resistance. But what we actually need here is, here we are calculating the voltage across this 3 ohm, because the voltage which is impressed across this 3 ohm is equal to the voltage impressed across this load resistance RL, right? So for that purpose we are calculating the voltage across this 3 ohm. So to calculate the voltage across this 3 ohm, we need to calculate the current that flows through this 3 ohm. So here the total current is 4 amps into opposite resistance here is 5 ohm divided by the total resistance is again 5, right? We need to calculate the current that flows through this 3 ohm, right? And this 3 ohm, it forms a part of 5 ohm because 2 plus 3 gives 5, right? That's it. So total current into opposite resistance divided by total resistance. So that gives the answer as 2 amps. So the current flowing through this part is 2 amps. So the voltage across this 3 ohms is 2 into 3, that gives 6 volt, right? Now the next step is calculating the Thevenin's impedance or Thevenin's resistance. So here in this case, again here we have to look back like this. So assume a current flowing like this at this node gets divided into 2. Similarly, again this current when reaches this node, it gets divided into 2, right? So here in this case, while solving, you see these two resistors are parallelly connected, right? So 10 into 5 divided by 10 plus 5, that gives 3.33. So this combination comes in series with this 2 ohm, right? So 3.33 ohm is in series with 2 ohm. So just add 3.33 plus 2, that gives 5.33 ohms, right? Now this 5.33 comes in parallel with this 3 ohms. Therefore here the net value is 1.92 ohms, right? So when you redraw the circuit, here we are having a voltage source and here we are having the R Thevenin, right? And this is your RL, right? So maximum power will be delivered to the load only when this value of RL is equal to this source resistance, right? This resistance is known as source resistance. So here the value of RL is again 1.92 ohms. So the current is, the value of IL is nothing but it is 6 divided by 1.92 plus 1.92. So that gives the answer as 1.5625 amps here. Now the next thing is power delivered to the load. So here power delivered to the load is given by the formula I square R, right? We know the value of I, we know the value of R. So just substitute the values and here the final answer is 4.67 watts, right? This is the maximum power delivered to the load resistance. Now we will move with the next problem. Here the problem is determine the load resistance to receive maximum power from the source. Also find the maximum power delivered to the load in the circuit shown. So here, right, this is the given circuit. So here again, the first step is we have to calculate the Vth. So to calculate Vth, we have to remove the RL, right? So here RL is removed and these are all the terminals. Okay, we need to calculate the, that is, just keep a note of this terminals here, A and B, right? Now, the current that flows from this 100 volt at this node gets divided into two, okay, I1 and I2. So now to calculate the currents I1 and I2, so this 100 voltage is impressed across this path as well as this path. So here this I1 is given by 100 divided by 10 plus 30, so that gives 2.5 amps. Similarly, I2 is given by 100 divided by 20 plus 40, so that gives 1.66 amps, right? Now we are going to calculate Vth. So to calculate the Vth, you see here, they are the terminals here, right? So either you can make use of these two resistors to calculate Vth or these two resistors to calculate the Vth. So here I am considering this part. So here I1 flows like this and I2 flows like this, right? So they are opposite to each other. So what is the formula for voltage? It is 30 I1, that is I into R, and here 40 I2, right? Since they are opposite to each other, here I had written as 30 I1 minus of 40 I2. So here it is 8.6 volts, right? Just substitute the value of I1 and I2 here and the final answer is 8.6. If you get a negative answer, no issues, right? We can assume that we can change the polarity of the terminals. So here you see, assume A is positive and B is negative, right? If we are having a negative answer, then just reverse it. A is negative and B is positive. So the next step is to find the Rth. So to calculate the Rth, here the thing is, so here you see again to find Rth, this is a terminal, right? So here these two resistors are parallel and again these two resistors are parallel and that combination comes in series. So here 10 into 30 divided by 10 plus 30 and here 20 into 40 divided by 20 plus 40. So when you solve, here the final answer is, right, here the final answer is 20.83 ohms here. So now when you draw the final circuit, here we are having a voltage, here we are having a Rth and here this is RL. Again, to deliver maximum power transferred to RL, the value of this source resistance should be equal to your RL. Therefore, RL is 20.83 ohms. Therefore, the current is 8.33 divided by 20.83 plus 20.83. That gives the answer as 0.2 amps, right? So, the next thing is maximum power delivered to the load. So, the maximum power delivered to the load is given by IL square, that is I square R, right? The value of this load current is 0.2 and the value of this RL is 20.83. So here just substitute the values and the final answer is 0.833 watts here. Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.